talk about circular shift register. So circular shift register. So what it means, we could actually, if we want to actually be more clear, so we actually want to make shift right with rotation. So what it means, so it means you have the similar things shift right. So we have 4-bit shift register. So remember, whenever that is the shift right, so whatever you had here, so to change the color. So in shift right, whatever you had here, you actually shift that to here. Whatever you have here is actually moved to here. Whatever you had here is actually moved here. And whatever you had in the last location, it's usually gone and eliminated. So in shift actually right with rotation, you don't want to lose the value of the last location. You want to somehow rotate that to the beginning of your bits, okay? So it should be shift. So that means very similar to the shift right. So technically you are shifting right, but in actually shift right with rotation, you are not losing the last value that you have here. You rotate that to the beginning of the shift register and you are able to keep whatever you have here. You are not losing the value that you have in this site. So let's see how we could design the actually the shift right with rotation. Definitely our tools is D flip-flop. So your shift register is 4-bit, so you actually use 4D flip-flop. I just put the 4D flip-flop here. So you actually start with this first one. Yeah, help me to design. So the first thing is the clock pulse. Definitely you have the clock pulse. This is actually sensitive to the rising age. So probably this is the most simple part of the design. Just connect all of them to your actually clock pulse and label that as a clock pulse. So help me, what should be the output of this connected to the which D flip-flop here? Whatever you have here should be the input of the next one. So that means this should be connected to here. So definitely you could call that whatever it's called. So you could say this is Y3. So if you consider this bit as a Y3, Y2, Y1, and Y0. So whatever you have here should be moved to here. So for that reason, you connect the output should be connected to the input of this. This is Y2. So the same thing, this should be goes there. This is actually Y1. You tell me where I need to connect these output. So if this is Y0, so definitely whatever you have here should be the input for this one, right? So that means this should be comes and connect to this part of this D. So definitely whatever you have here do actually the same thing. We will simulate that. So again, just let's see what we should connect to the clear and preset or set pins that we have. So similar with the others, the clear pins all connect to each other. We label one initialize int bar. So that means you just, before you start to work with this, just deactivate this for one time. So, and the all preset bar, this is the all CLRP, all of them. So, and the preset, we don't use them, we just deactivate them. So all of them connect to each other and connect to the one or VCC, which is we deactivated, okay? So that means it should be actually do shift right, and also we shift right with the rotation. So let's check the simulation and see in the simulation you actually see the same thing or not. So let's see which of these files, one of them should be, yeah, this is actually the shift right, okay? So as you could see here, this is actually the same design, and I just again stop the previous one. Okay. Yeah, I just implement the same design. Just double check the whole things. You have actually clock, the all clocks connect to each other. Connect to the clock pulse. What's the frequency of your clock pulse is actually is 0.25 hertz. Okay. So the preset, these three preset connect to one. In our design, we connect this to 1, 2. So the reason I actually connect the last preset to the switch, I want to actually able to produce just one, then able to see its movement of that one inside these shift register, right? Because if you don't have that, if all of them zero and you have actually shift right with the rotation, the zero, definitely you couldn't see anything on these LEDs, right? That's the reason I just connect to this. Just for the short time, I put that zero, make a one, then actually deactivate that. Then I will see how it's rotate that one inside this shift register. That's only difference with the origin design. So all of these preset is one, but the last one just connect to the switch, which I able to give 0 and 1. So initial pins, so all of the clear connected to each other and connected to these initialize input, which you are able to give 0 and 1, okay? So check the input output, so see the output of this connected to the input of this, the output of this connected to here, these output connected to these input, and these output connected to input. Why? Because we want to do this shift right, and then we want to have the rotation. We should be able to see that. So yeah, this is actually the same design we just implement in the simulation to simulate that. So we simulate that again, similar with the all previous shift register. We use these initialize, just put that 0 back to the 1. So that means I make everything 0. So it is circulate, but because just the whole thing is 0, we couldn't see that. So I'm going to just active this preset for a short time that able to make the one that I able to see how that one moves inside this shift register. I put that 0, it got gone, then I back deactivate that. So see, it's move here, it should be shift right, then should be here, it's move, then should be here, then should be here. Now see the rotation. Now it should be back here with the rotation, okay? It's back here. So see, that's actually the shift right with the rotation. It's here. Next should be here. Next should be here. Unlike the shift right, you are not losing that. So then in the next rising it rotate to the beginning of your shift register, okay? So again, if you want to actually see this move a little faster, so you definitely need a bigger number here, right? So I changed that to the 0.5. So to start that, just push that, initialize everything is 0, give just 1 and see how fast it's actually rotate and shift right. So it's still slow. So let's see. Let's just do this again. So I push this here, it is 0, then keep that 1 and actually turn that off. So it should be start to actually rotation, but somehow it's very slow. Let I change that frequency. So let me change to actually, yeah, that's actually the reason. Here should be put on the hertz. So here let to put on 0.5, okay? 0.5 hertz. So again, do the same thing, initialize. So yeah, it should be the simulation. The simulation initialize, it is 0, then give actually the 1 and should be rotate. Yeah, see this time it's actually, you have that shift register because I changed from 0.25 to the 50, it's actually going to be faster, right? So again, you have move here, so then again back here. So if back here, back here, back here, and again rotate to here, okay? So yeah, if you want to actually have more faster, definitely you could change the frequency of this if you want to get slower or more faster. So this is actually is circular shift register, and here we actually design and simulate shift right with rotation.